Hey there, welcome back to Road to Data Engineer. This is episode 26. So I've been gone for about 2 weeks. It's been 2 weeks since I posted an episode. Basically, what happened was I had some stuff come up 2 weeks ago that kind of made me put studying on the back burner for a week, and then last week I just didn't get back to it, but we're back now, so that's good. I'm glad to be back, and tonight should be the first night of getting back into the flow of working on my Python skills, my data engineering skills, my personal project, etc. So we're going to do a short session right now because my girlfriend is supposed to come over here in 40 minutes or so, and we're actually going to pivot today. So we left off working on learning about APIs a little bit, and we are going to finish that. But one of my goals for the month of August was to completely go through this Numpy tutorial on W3 schools, and it's the last week of August, so I really need to actually get after this. So we're just going to go through this. Basically, the idea is, I'm starting to use Python at work more and more as at my job as a data analyst. And a lot of that's going to be using pandas, which I'm already using to some degree. And Numpy is what pandas is built on top of. And as far as I understand it, it makes sense to learn both. And I think this will just give me more skills for my day job, skills that may come in handy for the personal project. I just think in general, it's good stuff to know and can't hurt me. And it's just something I want to do. So yeah, that's what we're going to do because I want to meet my goal that I set for August, and let's just jump right into it. So got the tutorial pulled up here, got my notes, and I got Python up. Import NumPy as py. Okay, NumPy is a library used for working with arrays. And let's get into the intro. What is NumPy? A library used for working with arrays. It also has functions for linear algebra, Fourier transform, and matrices. I do not know what Fourier transform is, so let's look that up. Fourier transform is an integral transform that takes a function as input and outputs another function that describes the extent to which various frequencies are present in the original function. Interesting. Describes the extent to which various frequencies are present in the original function. Interesting. Okay. I'm not going to act like I totally understand, but good to at least be exposed to it. NumPy was created in 2005. It's open source, and NumPy stands for numerical Python. In Python, we have lists that serve the purpose of arrays, but they are slow to process. Ooh, NumPy provides array objects that are 50 times faster than traditional Python list. NdArray provides a lot of supporting functions that make working with NdArray very easy. Arrays are frequently used in data science where speed and resources are important. Okay, NumPy arrays are stored at one continuous place in memory, unlike lists, so processes can access and manipulate them efficiently. This behavior is called locality of reference in computer science. Let's look this up as well. In computer science, locality of reference, also known as the principle of locality, is the tendency of a processor to access the same set of memory locations repetitively over a short period of time. Temporal and spatial locality. Temporal refers to the reuse of specific data and resources. within a small duration. Spatial refers to use of data elements within relatively close storage locations. Sequential locality, a special case of spatial locality, occurs when data elements are arranged and accessed linearly, such as traversing the elements in a one-dimensional array. Huh. Interesting. Source code for NumPy is located in the GitHub repo. NumPy stands for numerical Python. Boom. Oh, I probably should log into my... Okay, we're back after logging in to my W3 Schools account. What is an array object in NumPy called? IndieArray. Yep. NumPy is an open source project and you can use it freely. Dope. Let's check out the GitHub. Interesting. Interesting. I wonder what a PYI file is. Let's check that out. .pyi file. What is a .pyi file? Standardized way to describe API that's accessible from Python, but not implemented as Python code. Interesting. Huh. Okay. Okay. That's cool. Getting started. Installing NumPy. We already have it in Spider. Import NumPy. Okay. Now, usually imported as np. Okay, that's good to know. np.array, checking NumPy version under version attribute. Print np.version. Okay, sure. Print np.version. Let's see what version I have. 1.2.4. Okay. Creating arrays. NumPy is used to work with the arrays. The array object in NumPy is called IndieArray. Arrays. NumPy is used to work with arrays. The array object in NumPy is called IndieArray. I wish it would stop auto-capitalizing. we go, that worked. Okay. We can create a NumPy array object using the array function. To create an array equals np array 1, 2, 3, 4, 5. So I believe this would be a one-dimensional array type. This built-in Python function tells us the type of object passed into it. Like in the above code, it shows that array is a numpy.array object. So let's try this out. So we're going to do array equals np.array 1, 2, 3, 4, 5. And let's just check out the array and the type. Class numpy nd array. Okay. Makes sense. Use a tuple to create a numpy array. Okay, I wonder if it's any different when I use a tuple instead of a list. I would think not, but let's see. No, looks like it's the same. To create any array, we can pass a list, tuple, or any array object like into the array method, and it will be converted into an nd array. Dimensions of an array. A dimension in an array is one level of array depth. Nested arrays. Nested array are arrays that have arrays as their elements. 0D arrays. Or scholars are the elements in an array. Each value in an array is a 0D array. So I definitely want to write this down. So 0D arrays. 0D arrays, aka scholars, are the elements in an array. Each value in an array is a 0D array, i.e. np.array array equals np.array 42. Okay, let's try it out. Array equals np.array 42. Okay, so that's a 0D array. Makes sense. 1D arrays. An array that has 0D arrays as its elements is called unidimensional or 1D array. 1D arrays. An array that has 0D arrays as its elements is called unidimensional. Or 1D array. These are the most common and basic arrays. 1D arrays are the most common and basic arrays. That makes sense. I mean, they're essentially just a list. i.e. array equals np dot array 1, 2, 3, 4, 5. Okay. And next I'm going to guess is 2D arrays. (2D arrays). An array that has 1D arrays as its element is called a 2D array. An array that has 1D arrays as its elements is a 2D array. Often used to represent matrix or second-order tensors. 2D arrays are often used to represent matrices or second-order tensors. Numpy has a sole submodule dedicated towards matrix operations called numpy.mat. Okay. So here's an example. Array equals np dot array 1, 2, 3, and then 4, 5, 6. Oh, interesting. You have to close it in double brackets. Let's try this. See what happens when I do it like this. One, two, three. 4, 5, 6. Field elements must be 2 or 3 tuples. Got 4. Okay. Interesting. And I could probably do something like print array dot 1, which should give me this 4, 5, 6 array, I'm guessing. Yeah, it did. Okay. Makes sense. (3D arrays). An array that has 2D arrays, matrices, as its elements is called a 3D array. What is it like? Remove link. Oh man, this is fucking it up. have to actually copy and paste from W3 Schools itself, maybe? Maybe that will control the formatting here, I'm not sure. Oh yeah, I did. Not exactly sure why, but it worked, so it's good enough for me. Okay. 3D arrays. An array that has 2D arrays as its elements matrices is a 3D array. These are often used to represent a third-order tensor. Let's look up what a third-order tensor is. Third-order tensor. Analogous to rows or columns of a matrix, a third-order tensor has fibers. Since there are 3 dimensions to a third-order tensor, there are 3 types of fibers generated by holding 2 of the indexes constant. Interesting. That looks complicated. Create a 3D array with 2D arrays, both containing 2 arrays with the values 4, 5, 6. i.e. So let's create our own in Spider. Array equals np.array. And I'm going to do so that's going to be our first. Let me think here. Our first 2D array and our second 2D array is going to be here. Now in this first 2D array, we're going to have 1, 2, 3, and then 4, 5, 6. And then in this one, we're going to have 1, 2, 3, 4, 5, 6. I feel like something was wrong there. So here's our 2D array. Yep. I think I have a few too many. Okay, I think this should work now. Let's try again. Let's print array 0, which should be a 2D array. Yep. And now we're going to print array 1, index 1, and now I'm just going to print the whole array. Interesting. Okay. Check the number of dimensions. Numpy array provides the indim attribute that returns an integer that tells us how many dimensions the array has. check array dimensions. ND array objects have an ndim attribute you can use to check the number of dimensions an array has. I.e. print a dot ndim. Something like this. Okay, let's try it out. We're going to print, and this should say it has 3 dimensions. Nice, that's sick. That's sick. Let's try the W3 code real quick, just to validate it truly will print all my dimensions. Because we have a 0D array, a 1D array, a 2D, and 3D array. 0, 1, 2, 3, that's awesome. That is so cool. That it knows how many arrays there are. Higher dimensional arrays. An array can have any number of dimensions. When the array is created, you can define the number of dimensions by using the ndim argument. Array dimensions. Array dimensions, okay. Okay, so an array can have any number of dimensions. When creating an array, you can define its number of dimensions using the ndim argument. ndmin. Create an array with 5 dimensions and verify that it has 5 dimensions. I.e. array equals np dot array 1, 2, 3 ndmin equals 5. Let's try it ourselves. Array equals np dot array. We're going to do a 2D array. Let me think. 1, 2, 3, 4, 5, 6. Or I guess this would be a 1D array. No, it's a 2D. Just not a 3D. Because this is dimension 1 and dimension 2. Yeah, okay, a 2D array. But now I'm going to say my number of dimensions is 5. Interesting. Interesting. In this array, the innermost dimension, 5th dimension, has 4 elements. The 4th dimension has 1 element. That is the vector. The 3rd has 1 element. So that is the matrix. The second has the element that is a 3D, and the first is the element that is a 4D. Considering the following array, 1, 2, 3, 4, 5, 6, how many dimensions does it have? 2. Insert the correct method for, well, it's array, isn't it? Yeah, okay. Insert the correct argument. Create numpy with 2 dimensions. And then insert the correct syntax for checking the number of dimensions of an numpy array. ndim, I think. Nice. Okay. Array indexing. Okay. Array indexing. Array indexing is the same as accessing an array element. You can access an array element by referring to its index number. The indexes in NumPy array start with 0, meaning that the first element has index 0 and the second has index 1. Get the first element from the following array. Get the second element from the following array. That all makes sense. Get the third and fourth and add them. Okay, that all makes sense. To access elements from 2D arrays, we can use a comma separated integers representing the dimension and the index of the elements. You can access arrays much in the same way that you can access a list. However, once an array becomes 2-dimensional or higher, accessing it becomes more complicated. I'd say that's true. Access 2D arrays. I am not trying to paste. We can use comma separated integers representing the dimension and the index of the element. To access a 2D array, we use comma separated integers representing the dimension and the index of the array the element of the array we want to access. Hmm. 2D arrays are like tables with rows and columns. The dimension represents the row and the index represents the column. Okay. So an example of this would be np.array, array equals np.array, so we have our first array and our second array. Gotta copy paste again. Print array. So dimension 1 or 2, like let's say I want to print 8 here, I would say dimension 2 index, or index 2, I think. Maybe. Let's try it out in Python itself. Index 2 is out of the bounds for access 0 with size. So I think here, the row. Yeah, okay, so because this is considered dimension 1, but has an index value of 0. So that makes sense. Prints 8 from the array. So let's see. Access the element on the second row, 5th column. Print array on the second row, 5th column. So we want 1, 2, 3, 4, probably, and that should give us 10. Okay. 1, 4. So that was right. Okay, that's good. Accessing 3D arrays. Okay. Access 3D arrays. To access 3D arrays, we use comma separated integers representing the dimensions and the index of the element. Access the third element of the second array of the, sorry, what? So let's just try this out. access the third element of the second array of the first array. Access the third element of the second array of the first array. I think. Hey, I got it right. 0, 1, 2. Okay. Accesses the third element of the second array of the first array. In this example, prints 6. Okay. Example explained. The first number represents the first dimension, which contains 2 arrays. Yep, we're accessing dimensional. Makes sense. And since we selected 0, we are left with the first array. Yep. The second number represents the second dimension, which also contains 2 arrays. And then we selected the second one. The third number represents the third dimension, which contains 3 values, 4, 5, 6. Since we selected 2, we end up with the third value. You can use you can also use negative indexing when accessing arrays. Somebody might be at my door. Just a second. My girlfriend's here, so I will catch you guys later.